Alright. We're going through problem 14, which just confuses the mess out of me every time I do it. In modeling the number of claims filed by an individual under an automobile policy during a 3-year period, an actuary makes the simplifying assumption that for all integers n greater than or equal to 0, the probability of n plus 1 is equal to 0.2 times the probability of n, where P of n represents the probability that the policyholder files n claims during the period. Under this assumption, calculate the probability that a policyholder files more than one claim during the period. So we want the probability that n is greater than 1. Doesn't say 1 or more, which is why we're not saying greater than or equal to. It just says they filed more than 1, so it has to be 2 or above. Okay? And once again, you can find this sheet in the description box, the link to where to print it, so you can follow along, because I don't post the questions. Alright? Under this assumption, calculate the probability, blah, 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 blah. So the probability that n is more than 1 is equal to 1 minus the probability that n is 0, and I like to do these all together, plus the probability that n is 1. Doesn't really matter how you do it, but I like to look at it like that. It's a lot cleaner. Alright? So we need to figure out what probability of 0 is and probability of 1 is. From what we have up top, we know that we're about to go in an infinite loop of a bunch of stuff. Because it just says in a 3-year period. It doesn't say that you have to file 1 claim a year or anything like that. Just in 3 years, we have no idea how many claims you can file. So it can go from 0 to infinity. Alright? And I'll tell you why that's important as we go through it. So let's just go through some steps real quick. Let's say we wanted to find out what the probability of 0 is. So we have the probability of n, which is 0 plus 1, would equal 0.2 probability of 0, which should be the probability of 1 is equal to 0.2 probability of 0. Well, that's not helpful. Well, let's go to probability of 2. Let's just see what we can get out of this. Probability of 2 would equal, well, probability of 1, start there. Probability of 1 would be 1 plus 1, which is why I wrote the 2. Got ahead of myself. Probability of 2, 0.2 probability of 1. Okay. Well, what is probability of 1? So this is where you just, play with stuff. Let's see what we can do. This is also can be written as 0.2 times 0.2 probability of 0. Alright, we're getting somewhere. Well, what if we wanted to know if they had 2 claims? We're now at probability of 3 would be equal to 0.2 probability of 2, which is 0.2 times 0.2 times 0.2 times the probability of 0. Alright. Not helpful at all, but there's a pattern that we notice. For probability of 1, there's 1.2 times the probability of 0. For probability of 2, there's 2.2s times the probability of 0. For the probability of 3, there are 3.2s times the probability of 0. So the pattern we're noticing is if you want to find the probability of n, you need 0.2 to the nth power times the probability of 0. Okay? So, alright. Now we know that n is equal to that. How does that help us? This is the tricky part where I always get confused. Alright, what do we know? We know that all probabilities, which can be written way better than this. So I'll show you the notation that they use. Should be IES, but don't judge me. This is math, not grammar. The sum of all the probabilities from n equals 0 to infinity infinity will equal 1. Alright, so that lets us know that this is a geometric series. To which the first term is e over 1 minus r, where a equals the first term. This equals the common ratio. Okay. First term. 0.2 to the 0 times probability of 0. Works. And then over 1 minus common ratio, which is the first term we said would be 0.2 to the 1 times the probability of 0 over 0.2 to the 0 times probability of 0. Does that look right to everybody? These are crossed off and we got 0.2 to the 1. Because 0.2 to the 0 obviously gives us a 1. So here, this is a 1. 1 minus 0.2, which equals probability of 0 over 0.8 equals 1. Yay! This is starting to go somewhere. Alright, so what is the probability of 0 equal to? Well, I'm going to do my handy dandy cross multiplication of this invisible 1 down here. We got probability of 0 equals 0.8. Woo! So now we need the probability of 1. Well, probability of 1 will be 0.2 to the first times 0.8, 0.16. Don't get me to line up here. I'm not good at mental math. Alright. Yes. So now we want 1 minus 0.8, which we said was probably 0, plus 0.16. 1 minus 0.8 plus 0.16, which will give you a final answer of 0.04. Woo!